Warm greetings from Jaya School of Architecture. I welcome you all for the successful 12th session of this DECODE series. And today we have a very interesting topic on sustainability. The topic is integrated design approach and trends in the industry towards green by architect SAMHITA M. I now welcome architect Bhavya to deliver the welcome address and welcome note for the guest speaker of the day. Over to you, ma'am.
Thank you, ma'am. Good evening, everyone. Welcome to the 12th installment of the DECODE series. As Kavita ma'am said, today's topic is on integrated design approach and trends in the industry towards the green. I extend my warm welcome to our guest speaker for the day, architect Samhita ma'am, who has been in this field for more than 15 years. Welcome, ma'am. Thank you for joining us today. I'd also like to welcome our dean, architect Anita ma'am, and director, Professor Kavita ma'am, who have been trying very hard and working tirelessly to bring us the series. I'd also like to welcome architect Satish sir and the rest of the mentors who have been a constant guidance in our endeavor to bring you this series. Last but not least, I'd like to welcome our audience today. I'd like to present a short profile of architect Samhita ma'am. She has done her MA in sustainable architecture and she's associated with LEED, IGBC, Griha, and she's authorized in GMCH by the TPA and IGBC AP, and she's Edge auditor and expert also. She's an advocate of sustainable living. She is the managing director of Ella Green Buildings and Infrastructure Consultants, a company founded in March 2009. An architect from Anna University, Samhita ma'am's expertise lies in the planning, green and energy efficient building solutions, and driving integrated design approach in building design. Prior to starting Ella, she worked with Ashok Leland Properties and the CII Green Business Center in Hyderabad, where she was associated with all the prestigious projects of CII, ranging from developing of green building rating systems and formulating frameworks for certification of green buildings. Over the last decade, she has trained more than 8,000 professionals in the field of energy efficiency in buildings and green buildings. She has also consulted for more than 500 projects on green building services. Some of her clients include Infosys, Microsoft, ITC, Coal India, Symbiosis, and lots more. She has also worked with 5 different state governments towards implementation of the Energy Conservation Building Code, otherwise known as ECBC. She has also been awarded the Telangana State Energy Conservation Award and in recognition for her contributions towards energy conservation projects in the field. She founded Ella Green School in 2018 in Chennai with the prime focus of sowing seeds of sustainability in children at an early age. Today, Ella Green School is IT recognized and caters to more than 250 students. As someone once said, good design is sustainable, but a great one is responsible. Please, ma'am, take the dais and show us how to be more responsible with our design.
A very good evening to all the participants, and I'd like to thank the organizers of the session today to have me here and present a session, and also look forward to a discussion between young students who are aspiring to be architects or all those who are also already studying architecture to move into a green and sustainable space. I just have a little, I'm going to share something based on what my practice has been. I've been in this industry, although an architect by education, I've been more in the energy and green space for the last 15 years. And, from the beginning of this profession, actually, there was no such profession earlier to 2002 or 2005. And I've been there from the beginning. I'd like to just share a few trends, what has happened over the years and how it has actually developed into a new career option itself for us. So the first thing is, we spend so much of time in a building. 3/4 of a day we spend inside a building. And now, I mean, post the pandemic, we are actually spending a lot more time inside a building than outdoors. So how important is our building to create a healthy, happy space for us to be in? How many times do we actually, even people who create office spaces or large commercial complex or retail complexes, how much do we actually think of the user, the occupant that's going to spend at least 50% or 75% of his time inside the building? So one thing that we have noticed is that, and this is also, a documented thing, a fact, that 1/3 of the global energy, that is 33% of the global energy, is consumed by buildings. And I mean, can you imagine 33% is a large chunk, the remaining being industrial, transportation, and other sectors. So when our entire leadership is towards net zero by 2070, you can understand what an important role the building sector has to play towards this, the trend. In fact, I keep telling people, when there's collective action by governments and countries together, it can reverse the trend. It can reverse your climate change, which is the biggest threat today. A simple example would be our ozone depletion. The moment the protocols came into being, your Montreal Protocol, Kyoto Protocol, and we started banning chlorofluorocarbons, your ozone hole has reduced in size. Today, nobody's talking about that as a big threat. Now we have a different threat. So, building sector has a large role to play in today's industry, and how we can minimize energy consumption and make it a healthier space for occupants. And another thing is, in spite of the trend today, in spite of being more than 2 decades that we've been speaking of green, we've been speaking of healthy spaces, less than 5% of the existing building stock that we have currently today, globally, I'm not even talking about India. India will be much less than even 5%, are high performance buildings. So you can understand the need for energy efficiency, need for green sustainability. And what is critical in a country like India is we are a large developing economy. So just looking at green and sustainability in isolation to people, their basic needs, you cannot see it like that. It has to be a holistic approach. We need frameworks to implement. There has to be strategies, and how importantly, each of us have a big role to play in this industry. So, there are 2 ways to looking at this. One is looking at the existing buildings, okay? And that is a different approach. So here the engineers can come in, see what we need to retrofit, see how we can, set up a monitoring and verification plan. There's a different process to it. But what we can look at more intently, keenly is the new buildings. In the new buildings, how do we actually develop an approach? How do we have a framework? How do we go about in creating the best possible spaces at the least possible cost, and at the same time, least possible resources, energy, water consumption? So this approach itself is called the integrated design approach. It's nothing, there is no scientific terminology or something. It is just a collaborative approach where all of us sit together on the same platform, understand the design, and try and achieve the ideal or the optimal approach to design. So here we collaborate, we predict. So when I say we predict the building performance, we actually use scientific simulation tools, software tools. And in fact, most of my interns who come in and intern with us, we teach them software tools. So they become productive from the day one they join an organization. Today, architectural firms don't really use software tools because, we're still using the time-tested way of trying to develop a. But how do we actually bring science, and how do we prove our designs? So we want to move from being a subjective field to making it an objective field. If I say I have put a window here, I need to tell them that it actually adds this much value in numbers. So this is where we bring in the collaborative, predictive approach, and we therefore bring in optimization. So new buildings is where we are trying to focus on and trying to create a better approach in design. So here when I say integrated design approach, there are various, I always say we need a framework, right? So anything can be done, but unless we have a framework, a format to follow, which is what our green building codes or our energy codes talk about. So we look at codes and rating systems to just guide us, and it's not, I don't tell, what happens is people come and tell me it's just a rating. I said, yes, if you're looking at it as a documentation process, it's just a rating. But if you're looking at it as a tool to actually enhance your design process, that's where you can actually achieve the entire integrated design approach. So when I say I'll talk a little more on what the design approach itself is. We're looking at people who are using the building. Ultimately, we're looking at the planet, okay? Because in terms of we are using lesser resources, lesser water, lesser energy, minimizing our waste. In fact, people think that energy is the biggest crisis. Till now, even government focuses on energy. Our biggest crisis is waste, how we manage our waste. Our biggest crisis is water. These are the two bigger crises in terms of climate change and sustainability that we are looking. So all this will contribute to the planet. And most often people get confused when they say we are doing green or we're being sustainable, we are spending more. So I don't know if you have the time, but if we do, I will talk about how we've actually minimized our first cost, not only operational cost, but also first cost. So we're looking at profits also, the 3 P's of any approach. So what is the effect, the effect of design that we're looking at is we're first looking at reducing our carbon footprint, because any building is going to increase resources, disturb the earth, its surroundings, and so on. So how do we actually minimize the impact? There is no way we can't do without buildings. We are growing as a country, as an economy, and globally also. Infrastructure becomes critical. But how do we also reduce the carbon footprint? And today, net zero, this is net zero carbon neutrality is one of the is the new field that's emerging. Earlier, we never had this position of a chief sustainability officer. Today, it's a designation in companies. So now the new designation is chief carbon officer. That's the next new designation. So when we are studying, we don't even know what jobs are there for us. So it's important for us to learn and be aware of what's happening around us to prep ourselves for what is in the market. Adopt sustainable practices. So it can be anything from operations of the building to design, and then we incorporate technology. So what happens is most often when we say green buildings, people think we're going back to mud bricks, or we're going back to clay tiles, or we're going back to systems of design which are not scalable. Today we're looking at glass, steel, prefabricated systems, precast. I mean, technology is multifold. We have 3D monolithic structures, 3D printing technology. How do you incorporate technology so that we can minimize our costs? We can also use technology to advance in terms of green and sustainability, ultimately creating a positive environment. So I'll just talk a little bit about building codes and ratings, because these are becoming policies in the government today. These are as architects who are graduating or as professionals. In fact, there are consultants separately who do just ECBC, which is Energy Conservation Building Code. And they're mostly architects. So they may not be designing buildings, but they need to know design of buildings to be able to consult on this. So I'm just going to talk a little bit of this and what has happened as a result of regulations and policies. So earlier, energy efficiency in building design was never spoken about prior to 2007. Only the last 10-15 years, we're talking about codes. The government is saying we can't go on. So suppose there's power cut, what will you do? First, you will blame the government. The government is not giving us power supply. But what can the government do? Because power supply is coming from coal. We only have that much amount of coal. We can't increase our coal to the growth that we are seeing. So unless you reduce on the demand side, unless we say we can meet the demand supply gap. So only from 2007 onwards, the government itself is taking an impact and taking measures on demand side measures. So therefore, there are policies coming into place, and this is becoming a new field for us to look at, and how the market has transformed as a result. So just to look at it is a bit of, what are the existing policies and rating systems. There is the Energy Conservation Act of 2001, which is by the Government of India. Based on that act, only the Bureau of Energy Efficiency was set up, and they launched the Energy Conservation Building Code. It is not mandated in Tamil Nadu still, but it is mandatory in Telangana, Andhra Pradesh, Punjab, Rajasthan. So slowly this will also become mandatory in Tamil Nadu. It is under process, so each state has their own set of timelines. But it's important, but I think by the time you graduate, it will probably become mandatory. So then we have the rating systems, which are not governmental policies, but they are done by voluntary third-party organizations. But what is happening is these rating systems are becoming a part of governmental policies. Like, for example, your housing schemes, your banks, your, various people are saying if it's a green building, we'll provide loans. If there's more extra FSI, if this is a green building. So, although this is not a mandatory provision, it is becoming a part of governmental policies. Now, recently, the SAMHITA, which is another it's again by the Bureau of Energy Efficiency, which is launched for residential buildings. So, it focuses on daylighting, thermal comfort, energy savings, all these parameters for residential buildings, and most importantly, low-cost housing. So that is, something that's happening. And of course, I'm not going to dwell too much into all this because today we have any number of ratings. We have the Green Building, the US Green Building Council lead rating. There's EDGE, which is developed by the International Finance Corporation. There's IGBC. There's, India, we have mostly, the IGBC, USGBC, EDGE, and Griha rating that's happening. The rest are globally, but it's only a matter of time because everybody sees India as a huge market. In fact, LEED, the biggest footprint of LEED is next to America is India. India and China, America are all the largest markets for various buildings. So there are different types. If you're looking at just a park or sites, or if you're looking at parking buildings that are multi-level parking, different kinds of spaces have different kinds of rating systems that you can apply for. Again, I would suggest you to go into various, the websites. You have enough. Follow the social media handles because you understand what is happening. Because all of us are on Instagram or Facebook. So if you follow these pages of IGBC, or you'll know what is happening. Bureau of Energy Efficiency. What are the exams? They're going to launch the Building Energy Auditor exam. So those who are interested to make it a profession can see how you can qualify. So all these things. Again, just a brief about energy conservation building code is meant for commercial buildings, and it's only for new buildings and commercial buildings. There's a difference between what the ECBC or the ENS, which is the DECODESERIES, and green rating systems. Majority you have to understand is ECBC is mandatory, green rating is voluntary. ECBC and ENS focus only on the energy parameters, whereas green rating look at site, water, materials, indoor environmental quality, and other things. What is more important that we need to understand is how these codes and policies have actually driven the integrated design approach, how they've brought about a market transformation. Earlier, when we started in the industry, we didn't know what were volatile organic compounds. They will say low VOC paints. Then today we have Shah Rukh Khan who advertises, I think, for Asian Paints saying low VOC. So people may not know what VOC is also, but they do know that when they buy a paint, they should buy low VOC. Today you have air conditioners, refrigerators which have B star labeling. Again, that is to just identify with the market. You don't need to know what is star rating, what is the energy efficiency ratio. You don't need to know. You need just all that you know is 5-star means it's more efficient. So that is the kind of market transformation in products. In job industry, I told you, right? If you're moving into a different job, we have simulation specialists, energy simulation specialists. Most of them are architects. We have BIM specialists. We have CFD analysis, computational fluid dynamics. These are all different softwares in terms of understanding the wind flow patterns, in terms of understanding energy and understanding orientation. All these are various specialized courses. And again, you don't really need to do a master's in any of this. While you're doing your BR, if you start learning all these softwares, sometimes some colleges offer these courses. You just become adept at understanding design better. So just to understand what is the difference earlier when a design was done, the architect who's the main person will start the design and do the conceptual drawings. Then you'll finalize the design based on his approach to design. And then the drawing will go to the MEP consultant, the mechanical, HVAC, air conditioning, electrical consultant. He will use his rule of thumb. Then probably the client will say, I'll decide glass finally. After the building starts, if you start constructing, you will decide what glass to use. Meanwhile, you have designed the chillers oversized because you have not designed your glass. You have not decided on glass. You have not taken into account why the architect has done a certain parameter. So you're oversizing your chiller. You are consuming more energy. And you're not really doing an optimal approach. This is why we say all the consultants should sit on the table at the design stage together. Bridge the gap between the architect and engineer. Understand why the architect is saying what he's saying. Iterate through simulation. Suppose the architect says, let's do a roof insulation. But you do the simulation and you realize it's only contributing 1% savings. Whereas if you do high performance glass, it's contributing to 4% savings. So you'll be able to add value to the client. That is why we tell people, don't hurry us in design stage. Sit at the table. You expect once the concept is given, we're giving working drawings, the contractor will start, then we'll say we'll do this. So the whole approach itself is not right. So sit at the design table, do a complete analysis, then start developing the detailed analysis, drawings, whatever. So this is called a design sharing, and this allows for collaboration. And it's important that every green building that we do, we drive the integrated design approach. So when I say that is a specialized zone. Now we are consultants as a green consultant or as an energy consultant. We drive this approach because most often the client is unaware. Most often the architect wants to finish the job. The MEP wants to do it at his own pace. So for us to put everybody at the table becomes easier when you have a green consultant or a sustainability person on board. So now the market is shifting. Earlier, you just did materials. You did any building which cost less. You had single glass panels. You had buildings that became heat sinks. You had high-rise buildings coming up. That was substandard performance. Now we moved slowly to typical building practices. And slowly now, because of green building and all the codes, we are becoming green building leaders. But what we want to move to is green building innovators. We want to bring in innovation into our buildings. So this is the trend that we'd like to, and we're seeing it also slowly. And we still are not at the innovation, but green buildings are now becoming the norm. All your big projects are, going the green way. Again, so sometimes simple things like when Amravati was being announced, it was prime agricultural land. And they said they're converting 200 hectares of agricultural land into a city and then making every building green. Again, it doesn't make sense. So how we approach it from the site level is important for us as architects. So I just said, manufacturers. Earlier, insulation we couldn't procure here. Today we have local manufacturers. We have to import materials, things like, the waterless urinals. Today we have all these products at affordable. LEDs is a good example. LEDs were so expensive. Today everybody uses LEDs. And it consumes 100th energy of your halogen lamps. Similarly, opportunities are there in terms of professions. From when we started in 2009, as an organization, we have grown. The projects have come. It's just growing. I mean, there are so many consultants in this profession. It's become like architecture as a separate field. It's a subset of architecture, but yes, there are third-party assessors today. For example, I'm a third-party assessor for various governments in government of Andhra Pradesh, government of Telangana, where I become a certifying authority to certify projects because your CMDA does not have the expertise to look at a simulation software or a report and say whether it's right or wrong. So what they do is they hire, it's like a chartered accountants. This is becoming a new profession in the building industry. Again, courses, sustainability, architecture and sustainability. There are various specializations also happening in educational institutions. Again, these are some policies countrywide that has adopted green into their, governmental building policy. So you may want to go through. I'm not going into it. If we have another few minutes, I'm just going to talk specifically how there are various components of building design, which actually impact. Again, please feel free to add, or this is not any textbook material. It's purely from what our experience is. So it's not an airtight packet, and you can add or delete items here. So how these actually have an impact on your building. So most often, when we say energy efficiency, we think of building plan as different, as just design oriented. No, how you design your building in terms of function, shape, orientation, all this has an impact. In terms of landscape has a huge impact on the heat island effect and therefore on the building also. Your window to wall ratio, how much of glass you have on the window, on the facade. The choice of materials, the thermal properties of materials you decide. So today, in what is happening in technology, concrete becomes an easier versatile material. But concrete is also very poor, has poor thermal properties. It can become it has a larger propensity for heat gain. So how do you insulate your concrete? Shading devices. So there are various ways in which we can look at options. So just to talk about integrated design approach, we have specialists working together. So you learn How many of us actually, when we're studying architecture, at least I did when I was studying architecture, when HVAC was a design subject, I said, when am I going to do HVAC? That's not my area of expertise. No, you have to know a bit of air conditioning, you have to know a bit of electrical design, you have to know a bit of climatology. Unless you know a bit of everything, you cannot steer your design to the best possible outcome. You have to look at the building and the site, how climate interacts with the building. So without studying the climate, you cannot start your design. How do various components of the building interact with each other? How does the air conditioning interact with your glass? How does lighting interact with your interior materials? How does every aspect, there is a relation with each other. So you as an architect has to drive the relationship. You cannot have the electrical consultant expect him to know what interiors you have given for him to give design accordingly unless you drive the approach. Similarly, most importantly, only if everybody sits together can you achieve innovation. Otherwise, you cannot look at any innovative approach. So this is the gist of it. So an ideal approach would be to start with the site. When I say site, we're looking at climate, we're looking at land use, landscape, the air, the movement of wind, orientation, solar access, topography, how views, because most often people think views is only an aesthetic element. Only if you can connect to the outside and views can an occupant work effectively and productively inside a building. Most commercial buildings, you go to any office space, the center of the building will be open office. Peripheral, they have the cubes. So only 15% will be sitting at the peripheral with access to views. Whereas your majority, 80% of the people will be sitting inside using artificial lighting, not knowing what is happening outside. So how do you expect them to perform? Well, so then you look at building design. Here you use various tools. You use the shading, microclimate, you look at building materials, insulation, air conditioning, all those designs. And finally, we look at how the building can operate. So this is the trias energetica approach is basically a three-pronged approach towards net zero. So when clients come and say, can you design my building? I want my building as net zero. No, I can't do any net zero here. I can only give you towards net zero design. First step would be, can I make sure my building can consume least possible energy without any artificial air conditioning? So suppose I am able to cool my building. If my building by design is say 5 degrees or 6 degrees lesser than the outside temperature, that means my air conditioning will, instead of cooling from 40 to 24, it will cool from 35 to 24. So there I'm saving energy. That is where my first pronged approach will come. That is towards net zero. I cannot completely eliminate the use of air conditioning, right? At least in places like Chennai or very hot and humid. Then you look at high efficient system design. Again, this you look at high performing chillers, how the coefficient of performance, you look at various parameters. Again, you bring down the energy consumption to the least possible. Then you bridge it with renewable energy. Why I'm talking about this towards net zero approach is today that is the buzzword. Everybody is talking about net zero, carbon neutrality. So it's important that you understand what net zero is. It just doesn't mean replacing energy with solar or grid. You have to follow this three-pronged approach to achieve your net zero. Also the trias energetica approach. And yes, all of us do know climate dictates most of this. I'm going to just quickly run through. I think we are close to the end of the session. Am I right, ma'am?
Yes, ma'am.
Okay, so I'm just going to quickly run through how we have how we apply all these parameters: sun, wind, temperature, relative humidity, microclimate into our. These are some snapshots of the simulation software. Just like your 3D Studio Max, where you're creating an aesthetic model, here we are creating functional energy models, or to understand the impact of the sun path, the energy, all of those parameters. So this again is just a diagrammatic representation of what I had spoken earlier. The design will have an impact on the plan, the window to wall ratio, landscape shading devices, and the kind of materials we use on the facade of the building. So most importantly, even landscape can reduce your building, the energy consumption by a large amount. In fact, there's a 9 degrees differential in between. In fact, the US Lawrence Berkeley laboratory has done a study, and they measured temperatures in the same space under a tree over a black car top road, and they find a 9-degree Fahrenheit differential between these two temperatures. So how important it is to have trees and landscape around. Similarly, planning and built form. How do you place your functions in your building, which require least lighting, artificial lighting? So if it's a school building, you don't have to use artificial lighting at all. How do you plan that? Things like that. This is again a plan of Symbiosis, where they have created, Symbiosis University in Hyderabad, they've created pocket spaces everywhere to bring in maximum lighting. Architect is Moti and Maniam Associates in Hyderabad. This is again a Coal India corporate office building, which is done by Rajraval Associates in Calcutta. Again, hot and humid climate. You see how he's put the open office completely in this V-shaped floor plan, allowing the central courtyards to bring in light and views to the open office areas. And also, if you see, he's opened the building, the step form here, so that the lower floors also, it doesn't form a complete cylinder. Even through your lower floors, you get enough lighting when you open up the building. See how he's given the external shading. He's given reflective glass so that, I don't know how many of you have actually gone and seen the Zoho building in Gudwajari. It's a complete circular glass building. Inside there will be blinds. From outside you can see if everybody is using blinds, then what is the purpose of having glass? So again, here to provide, to cut out glare and to allow daylight also. So we have, as an architect, we have to think of various of these parameters before we actually go into the depth of design and understand this. Again, orientation, you all of us know, basic is east and west is maximum harsh sunlight. So how do we buffer the east and west and have north and south, more glass, more daylight coming in from there? So these are some principles that have gone into, this is again CPCL dining hall, where the entire the glass elements are placed on the north facade with some kind of shading to make it aesthetically pleasing. At the same time, it impacts the glass. This is an orphanage building again. The entire orientation is towards the north with shading elements to keep the children comfortable during peak summer. I think all of us have seen this just for students to understand, these are two buildings of similar sizes, but we don't want to create heat sinks, fully glass. We would like to bring in glass, but how functional is glass is also important, and aesthetics, we can always work it around, right? Similar, these are some options, right? First option gave us only 29% glass. There was not enough daylight. Then the architect worked back and gave us the second option to achieve more daylight. So it can work vice versa also based on daylight within the building. Again, this is a simulation analysis of the Coal India corporate office building to understand its impact. So what I'm saying is all this will, you can be very confident of your design only when you go with these numbers. Otherwise, we are only talking subjectively, and that doesn't, it is being seen as an art subject. No, we have to look at architecture not as an art oriented, but it's a blend of engineering and science also. So, shading devices, you can have any ways how you can plan your shading devices. And the most important is, none of these ratings or these policies actually restrict your design approach. They only enhance it. It only gives you guidelines, but for you to design it, the design is completely within the scope of the architect. Some of the projects where we've done various shading elements to understand. So heat gain is maximum for glass, and that is important for us, and therefore we look at materials, how we minimize the heat gain into the building. So these are some of the projects where we've used, roof insulation with the clay tiles. We've started with coir for additional insulation. We've done a rat trap bond. So there are various ways in which you can achieve, given our constraints also. Okay, each project will be, some will be a large campus, so you can play around with the area, some will be restricted size. So it has to be a box building. So again, it's up to the architect to design. So I think with here I will, end the session because I think I've passed my time. And maybe in some other session, I'll go into a detailed case study of how we can achieve with all these concepts, how we can actually achieve whatever I spoke, how we've done it in real life is something that probably will take it on another day if the opportunity is given. And any doubts, you can let me know. I'll be happy to.
Thank you, ma'am. Thank you for such an, it was very informative and very intense session. I'm sure such intense topic cannot be fitted in 20 minutes or 30 minutes. I'm sure we need more sessions like this to learn a lot from you, ma'am. Thank you so much. As of now, we don't have questions in the chat box. I now request Dean ma'am to give the vote of thanks, a few words for the guest speaker today.
Thank you very much, Professor Kavita. Our sincere gratitude to Architect SAMHITA. It is an awesome set of information. I'm sure the children have just, got it inside that, yes, now we have a source to whom we can refer. I'm sure that there are many students who are going in for thesis who would have found this an eye-opening session, and they would definitely want to, experiment with the same thoughts and get back to you for a little more clarity. So it is the need of the hour. And as you said, it's going to get mandatory very soon in Tamil Nadu also. It's not too far away. And you will be in great demand for the children.
Sure, definitely. My pleasure, ma'am.
And I must say, I had the pleasure of visiting Architects Ella School, and everything that she spoke has been implemented there. I did witness the nearly 12-degree variation, and there was no fan, and there was no need for additional active ventilation. And the only feeling that I had was how I wish we all learned to do this much faster. And not, prolong till we to go to that point where then we learn it and then we are at the loss.
Right.
So thank you for showing that bit where the process and where you have to introduce it. As I saw that slide, and I know how relevant that was. Thank you very much for today. And we will keep in touch and we will collaborate further. Thank you so much for today, madam.
Thank you so much.
Thank you to our head of the institution, Dr. P. Satish Kumar, who has been the wind beneath our wings, pushing us to get this thing done for the entire fraternity. I thank all the participants who have come here. I hope this was great information for you. And you can please connect to Jaya School of Architecture, and we can definitely put ma'am across to you for whatever doubts and questions that you have. We can bridge that for you. Let's meet again tomorrow for another interesting topic. Short, sweet sessions, 30 to 40 minutes. We'll meet again tomorrow evening. Thank you.